I spent. Where were you? Now he's asking for velocity of block C and A. So this will descend by H. Then he's asking. So first of all, definitely the blocks will have velocity. So VA, VC. Looking at that, block B and C will have common velocity. VB equal to VC. They're connected by common string. The speed of the block B should be equal to speed of block C. Then we need some relationship between them. This is connected. So if you go back to the constraint equation, the change in length of these segments is equal to displacement of this block A. The change in length of these part of strings is equal to displacement of block B. Hope if you can remember. So therefore I'll call this as XA, 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 XA. This XB, this XB, XB. Of course, this length, this part of segment will remain same, but from year to year it will change, no? So still I can write this as XB only. This will remain constant. Okay, now total overall length of the string. So we are measuring the length of string from year to till year. Okay, there's some point, I'll write it, it'll be easy for you. From year to year, we are going for the length of the string here. So total length of the string should remain constant. L should be equal to 4XA plus 3XB. So from the constraint equation, 4VA equal to 3VB. And VB equal to VC. They're connected by common string. Okay, till here we have this much here. Okay, let's go for the free body diagram. What are the forces acting? Tension, mcg. Then this tension. Okay, here you call T1, T1. This tension, let me call T2. Here it will be 2T2. I can't show in all 2T2. Here it should be 2T2. Then, who does work on the block A? The tension. Who does work on the block B? This tension T1 and also this T2. And the normal reactions are acting. The normal reactions will be Na, the weight Mag, Nb, Mbg. So, now can we apply conservation of mechanical? The only thing is I wanted. When we can apply conservation of mechanical energy? When only conservative forces are doing work. This tension does any work? Yes, it does negative work on the block C. It does positive work on the block B. This tension, T2 tension, 2T plus 2T2 plus 2T, 4T2, 4T2 will do positive work on the block A. And look at the 3T2 tension, it does negative work on the block B. Along and the normal contact Na and Nb and Mag, Mbg, they don't do any work. Okay, agreed, fine. So who are doing work? The weight of the block and the tension the strings. So when you can apply conservation of mechanical energy? When all the forces are okay, let forces several forces are acting and they're doing work. Net work done by only conservative force is non-zero. Then you can apply conservation of mechanical energy. And what about tension? Tension is not a conservative force. Will not come under category of conservative forces. So therefore, can we apply conservation of mechanical energy? The answer is no. But I do apply this, I'll get the answer. I do apply it. Sir, what about this? You are saying tension is not a conservative force and conservation of mechanics is applicable only when conservative forces alone does work, but tensions are doing work. Let's do one thing. Let this have a displacement XA, XB. I think we have relationship between XA and XB also. If XB moves some distance and XA, so they are related by this equation. So delta XA, I'll go for delta XA, this delta XB. Now how delta XA, delta XB are related? The constraint equation is 4 delta xa equal to 4 3 delta xb. You differentiate this, nothing is there. Delta L will be 0, delta xa, delta xb. Sir, what you do with negative sign? If this length decreases, this will increase. Already we have come across in laws of motion. Now, work done by tension will calculate. Work done by tension. Net work done by tension. Tension does 4T2, no? 4T2 into delta xa. It does positive work on the block A. It does negative work on the block B. It does positive work on the block B, and it does negative work on the block C. And what is another equation? Delta xb equal to delta xa. They are connected by a common string. Then delta xa very beautiful. This is what I wanted. Students, really I wanted you to go back. We have so many problems of laws of motion. There are 180 numericals are there. All that 180 numericals, if not all, at least few, take them, which contain so many other. Try to understand that instead of finding acceleration, let this hanging block, let it have a displacement h, and what is the velocity of them. Like their normal contact will come, weight will come, tension will come, friction will come. The net, though tension does work, net work done by tension is 0. Then what is only net force, what is the net work done by only force? Non-zero, the weight. So therefore I can apply conservation of mechanical energy. So one more conclusions. Now this will be very, you can say, essential for us. The total, what all we wanted to learn, this work point, to solve such numericals. I don't know, like in books what will happen. They're focused more on that math-based questions. But in coming chapters, yesterday what I discussed, no, I don't think so I'll be using such things very often. But these are things which will come very often in our coming physics. So way to find out such problems. Questions will not be there, but diagrams will be there. No, go back to laws of motion. You have so many questions of this kind. Instead of asking acceleration, finding acceleration, find out the velocity here. Work done by normal contact. Work done by all 0. So what is the only force doing is this one. So decrease in gravitational potential G of block C is equal to increase in kinetic energy of blocks. Decrease in gravitational potential G, mcgh equal to ma va square mb vb square. Mass of each block is m. Okay, that is there. So va vb, how they are related, substitute all, you'll get the velocity of block A and C. Solve it. I'll go for next problem. This will be mgh m by 2 va square m by 2. What is vb? Vb will be 4 va okay, I'll do one thing. I'll replace va, I'll replace va will be 3 okay, solve for vb, you'll get the required answer. This is the thinking part. Here is what so much of thinking is there. This has to be, you have to make observation, nothing is there. On one side you know constant equation, on one side you know how to get the tension, the string, then tension in each block, what work it will do, then verify